Okay, so today I wanted to just review complete and anionic equations. This goes along with double replacement reactions or neutralization reactions. And so here's kind of a classic example of an equation you might see. Silver nitrate plus sodium chloride. What's going to happen is silver nitrate is AgNO3. You're reacting with NaCl, and then everything's going to switch partners. So Ag is going to be with Cl, Na is going to be with NO3, and this is what the product's going to look like. Now, if you were to visualize this as a particulate diagram, looking down inside the actual reaction itself, this is what you would actually see. So the Ag and the Cl are both aqueous. So everything, let me back up. Everything on the reactant side of the equation is going to be aqueous. So, and you can see this here, that Cl is ions by itself, silver is ions by itself, and so is sodium, and so is nitrate. So everything on here is going to be aqueous, kind of floating around in the solution. Then when you combine them together, what's going to happen is AgCl forms a solid, and so it's going to clump together as a solid product, but Na and NO3 are still going to be hanging out. And so the non-ionic equation just shows what is actually forming the reaction. And in this case, it's the Ag and the Cl is going to form to give us AgCl as a product, where sodium and nitrate are just going to hang out. So they're what's called spectator ions. And the analogy I've used in class is like a sporting event. If you go to a football game, there are literally two groups of people in that stadium. One is the players on the field that are actually participating. In this case, it would be silver and chlorine. And then everyone else that is just watching or just a spectator. So just hanging out like sodium and like nitrate to make that happen. So this just kind of shows you a visual of how that occurs. Now, chemists normally use three different types of equations, and so it's really important to be clear on all three of these. The first one is a balanced equation, which I showed you on the previous slide. The next one is what's called complete ionic. And in a complete ionic equation, everything is broken apart except the items that can form solids, liquids, or gases. So if you notice from this equation down to this one, everything that's aqueous is going to be broken apart. So we have Ag plus aqueous, NO3 minus aqueous, sodium's aqueous, chlorine's aqueous, and on the product side, the only thing that's going to be together is AgCl because it forms a solid. So that's going to be together, but then sodium and nitrate are also aqueous. So they're going to be split apart. Then what's going to happen is for non-ionic, you only worry about the things that are reacting. So anything that's the same on both sides of the equation, you can cross that off. If you notice, nitrate is the same on the left as it is on the right, so we can cross that off. The same with sodium. That's going to leave us with Ag, Cl, and that'll form AgCl solid for that. All right. So again, the terms to keep straight: complete ionic is everything broken apart. Non-ionic is the things that are reacting together. Spectator ions do nothing. They just sit there. So anything on both sides of the equation you can eliminate and you're good to go. Here I have some practice problems. In class, we worked out one of these. I had you guys choose. If you need more practice, like do the other two. I would pause the video and try to do these at this point, then restart it. I'm going to walk through each of the problems, and then you should be good to go on this. All right. So again, pause, work out these three problems, and then move on. Okay. So the first one here is lead-2 nitrate and ammonium chloride. Lead-2 nitrate as a formula is going to be PbNO3 2. We know it's going to be aqueous from the solubility rules. Then we have ammonium chromate. Again, ammonium is NH4 chromate CrO4. Again, that's aqueous. And what's going to happen is you're going to form lead chromate, and then we're going to form sodium nitrate, NH4NO3 for that. And again, when you look at the solubility rules, chromate will form a solid when it's with lead, and then these two will form aqueous. So the complete ionic, we break all the aqueous parts apart. So lead, nitrate, ammonium, chromate. Then on the product side, lead chromate will be together as a solid, so we do it as such. Then the other two will be aqueous, and the net ionic will be Pb2 plus, CrO4 minus, and then PbCrO4 will be a solid. For silver nitrate and sodium sulfate, balanced equation for that will be 2AgNO3 plus Na2SO4 going to 2NaNO3 plus Ag2SO4. Again, solidity rules is how we got this is aqueous, this is aqueous, this is aqueous, and this forms the solid. Complete ionic, all the aqueous are split apart. So we have 2 silvers, 2 nitrates, 2 sodiums, 1 sulfate, going to 2 sodiums, 2 nitrates, and then Ag2SO4 will be together as a solid. Net ionic, when you break everything down, we'll have 2 silvers, we'll have 1 SO4 2 minus going to Ag2SO4 to make that work like this. Third example here is strontium chloride and lithium sulfate. Balanced equation is SrCl2, Li2SO4 going to 2 LiCl plus SrSO4. Again, you get this, so Sr is 2 plus, Cl is minus, lithium is plus 1, sulfate's 2 minus to make this work. And then the states come from solubility rules. Complete ionic, same process we've done before. All the aqueous are broken apart. The ion that's solid is here. Then when you pull everything out to get the net ionic, you'll get Sr2 plus SO4 2 minus to get SrSO4 solid for that. Do you have any questions on this? Let me know. We will test over spectator ions, balanced equations, complete ionic, net ionic, all that stuff will be coming. So, but as long as you can do these problems, you're going to be in good shape for anything I throw at you on a future quiz or test. All right, that is all I have for today, and we'll cover this topic in more detail.